All right. So I picked out 3 questions from old AP exams about experimental design, which is what we're doing now. How do you design an experiment? So all 3 questions are on the first page. The rest of it is how these get scored. I score AP calculus questions in the summer and have for ages. I enjoy doing it. You would have to pay me a lot of money to make me do the stat ones because you have to, I mean, how you score it is multiple pages long. You'll see in just a second. All right. So these are all free response questions or parts of, like number 4, the first one is just the first part. All right. So the anterior cruciate ligament, ACL, is one of the ligaments that helps stabilize the knee. Surgery is often recommended if the ACL is completely torn, and recovery from the surgery can be lengthy. Told you he was coming. A medical center developed a new surgical procedure designed to reduce the average recovery time from the surgery. To test the effectiveness of the new procedure, a study was conducted in which 210 patients needing surgery to repair a torn ACL were randomly assigned to receive either the standard procedure or the new procedure. Based on the design of the study, would a statistically significant result allow the medical center to conclude that the new procedure causes a reduction in recovery time compared to the standard procedure for patients similar to those in the study? Explain your answer. So what do you think? So yeah, the short answer is uh-huh.
So just to remind myself, statistically significant means that it's too much of a difference to just happen by chance.
Correct.
So that means that whatever we were doing to try to improve the recovery time.
Well, it's a different surgical technique.
Right. So, but that we're saying if it's statistically significant, we're saying the difference between that and the old procedure is so significant that it's very likely that it is the new procedure that makes the recovery time shorter.
Well, we can't say that until we look at what they did.
Oh.
So let's look at what they did.
Okay.
So one of the things we have to do in an experiment, what are the things we have to do in an experiment? What's one of the primary things we have to do?
Randomize.
So randomize what?
Oh, the treatment that's assigned to the subject.
Right, random assignment of treatment. Do we have that here?
Yes.
Yes.
Randomly assigned.
Yeah, it says this. They were randomly assigned to receive, so the 210 patients were randomly assigned to treatment. Why is randomly assigning treatment important?
So there isn't any bias.
I can't hear you at all.
So there isn't any bias.
Okay,
Like-
bias is for samples.
Oh. So there isn't any other confounding variable.
Right, so there can't be any confounding variables, or there's less likely to be confounding variables.
A confounding variable is a
Confounding variables and lurking variables, not the same thing.
what's a confounding variable?
So I'm going to show you in just a second.
Okay.
Yeah, hang on to that. Which should limit or eliminate any potential confounding variables. And I would probably list some. such as what other things do you might have to do with somebody's recovery from this?
There.
Just
Um,
Could be their activity.
okay, such as their general fitness.
Like their other injuries? Could that be one?
Probably not.
physical therapy, the extent of their physical therapy.
Okay. Physical therapy. Think more generally. Age,
Oh, yeah.
right? Might have something to do with it.
Could diet be one?
It could be. It feels like a bit of a stretch,
Yeah.
but I'm going to include BMI,
What is that?
body mass index.
Oh.
It's a way of telling how fat you are.
You don't want to see Savannah's body mass index.
I don't have enough fingers on my hand to get there.
You'll have a printer that can print out such a big sheet of paper.
I don't even think there's a calculator possible. Maybe if it's a calculator.
All right, so let's look at, on page 2,
Oh, that's it?
what they said. Said, yes, it would be reasonable to conclude that the new procedure causes a reduction in recovery time for patients similar to those in the study. Although they parroted what they said, it was a yes or no question. So I felt free not to write all of that. The patients in the study were randomly assigned to the two procedures, which reduces the chance that confounding variables will affect the results. And I probably should have said, therefore, the statistically significant reduction in mean recovery time can be attributed to the new procedure, which is what Brody was saying. Okay? So let's add that. Therefore, the reduction in recovery time can be attributed to the new surgical procedure. Okay, so these are all examples of confounding variables or potentially confounding variables. So we try to control for those by randomization. It helps me get rid of all those. All right. Here's one that has a bit more to it. I think this may be the whole question. Alzheimer's disease results in a loss of cognitive ability beyond what is expected with typical aging. A local newspaper published an article with the following headline: Study finds strong association between smoking and Alzheimer's.
So did you, on the last one, have only gotten partial correct? Did you
Actually, let's look at that real quick. Correctly states that it's reasonable, all right, I did that. Justifies the causal relationship based on a random assignment of patients' procedures, or justifies the causal by stating that the randomized experiment was conducted. I think it would have gotten everything. I did it in the context of the situation.
Yeah.
And then they have all these partial and incorrect things.
So like for that one, if we didn't say that fancy sentence that they had at the end where it's like the mean
I-
and then if we didn't say like that fancy sentence where they had at the end where it's like the statistical significant reduction in mean recovery time and that whole thing. If we didn't say that but we just said that the what's it called? The difference was so significant that we knew it wasn't just by chance. If we said that, that's fine.
Yeah, there's lots of leeway in this. All right. So, the article reported that a study tracked medical histories of 21,123 men and women for 23 years. The article stated that those who smoked at least 2 packs a day, the risk of developing Alzheimer's disease was 2.57 times the risk for those who did not smoke at all. Yeah, 2 pack a day a habit is a lot.
That's a lot. 2 packs is a whole thing. Like a whole. It's a whole
Like
pack.
6 in a pack.
How many cigarettes is that?
How many cigarettes are in a pack? I have no idea. I've never smoked, so,
Oh wow, good for you, Mr. Davis.
well,
We're so proud.
yeah, cigarette smoke makes me sneeze, so.
Never
Maybe
mind.
like 12.
12?
I thought it was like 12.
We gotta start smoking at like 8 a.m.
It's more than 6. I think it's 12. It may be more.
Doesn't an average cigarette only last like 30 minutes?
Mm.
My dad.
All right, so what is the explanatory variable here?
Explanatory? Are
How?
smoking? How much is smoking?
How long they're smoking?
How much is smoking?
How?
Okay,
Yeah.
so the explanatory variable is how much a subject smokes. What's the response variable?
Risk of developing Alzheimer's?
Yeah, or not. So developed Alzheimer's or not.
So you kind of, on that one, you have to do both, or not, or if it did.
I'm sorry. I caught part of that, but not all of it.
Like, for the response, do you always have to say, like, whether they did or didn't? It's not just like, if they did. That makes sense?
Yeah, I would do both.
Okay.
So, is this an observational study or an experiment?
Observational.
It's observational. And although they didn't ask, is it retrospective or prospective?
I was just gonna ask that.
Wait.
Prospective.
Wait a minute. You said prospective. What did you say?
Prospective.
You're both wrong. It's retrospective.
No.
Because you started.
They picked a group of people and they looked backwards in time.
Oh, I thought they looked forward
I think
because
that's before as well.
they're seeing if they develop Alzheimer's.
Now, tracked the medical histories of these people.
Oh, dang it.
So it's an observational study. Why is it an observational study?
Because there's no, like, control groups. What is the treatment?
What is it that differentiates an experiment from an observational study?
There's no treatments.
Randomization.
Well, put them together and you've got something.
There's no randomizing treatment.
Yeah, there's no randomization of smoking levels. And I guess I'll say no randomization in assigning smoking levels.
Could you also, or could you get that question right if you also said like, you're just observing what these people do, you're not like changing them or like putting them into groups based off what they do?
The randomization of treatment is the hallmark for, that's what makes it an experiment. So exercise status, regular weekly exercise versus no regular weekly exercise, was mentioned in the article as a possible confounding variable. Explain how exercise status could be a confounding variable in the study. So remember, in the end, their conclusion is that people who smoked 2 packs of cigarettes a day were way more likely to develop Alzheimer's disease than people who didn't smoke at all. Yes.
Possibly
Yeah, it may be that people who smoke 2 packs a day, being less health conscious, were less likely to exercise.
What's the difference between a confounding and lurking variable again?
So a lurking variable is one that does both. So for example, here they're trying to show a link between smoking and Alzheimer's disease.
A lurking variable could be, isn't Alzheimer's hereditary? Or no?
I'm sorry?
Isn't Alzheimer's hereditary?
No one's quite sure.
Oh. Well, if it was, a lurking variable could be like if it runs in your bloodline.
No, because that doesn't affect smoking. A lurking variable will be something that is the real cause, that affects smoking and affects Alzheimer's. I can't think of a good lurking variable for that one.
Like if you grew up around people that smoked. I don't know. If you grew up in Greece.
Yes, my wife said the same thing after being in Greece. She's like, everybody smokes.
Yeah, Franks too. So there's cigarettes everywhere. It's just in the air. You kind of get used to it.
But a confounding variable just affects the. like
So
the-
confounding variable is something that affects my response variable, but I haven't accounted for it in any way.
Oh, I thought that's what a lurking variable is.
A lurking variable is one where we haven't identified it. But it's the real cause. So the one that's on AP Central or AP Classroom is one where schools looked at the achievement gap, which is students from lower socioeconomic groups did worse on this math test. And when one goes up, the other one goes up, one goes down. They're parallel pretty much all the time. And so they looked at that and they were like, oh, people who are from these lower socioeconomics groups have a lower attendance rates. Attendance is the cause. So they did all this stuff to raise attendance. And they raised attendance. And the grade stayed the same. So attendance wasn't actually the cause. The cause is something else. Maybe they have less time because they're working, or they're having to take care of younger brothers and sisters because their parents are working multiple jobs, or nutrition, or any of a number of other things. That's the lurking variable that's the actual cause, as opposed to attendance, which seems like it might be a cause.
Okay.
Okay? So let's see what this says about this. Man, it's a long way down. I put the whole thing in here so that if you want to look at it, you can look at all of the things that they're looking for. So the explanatory variable is the degree of cigarette smoking. The response variable is whether the person develops disease during the course of the study. All right. It's an observational study because the people in the study were not assigned to a certain degree of cigarette smoking. Rather, and I was content to do that. They went on and said this, which is probably a good thing to say. Rather, the degree of cigarette smoking for each person was passively observed. We didn't manipulate it.
Yeah, that's what I was asking. If you can say that, like, just that it's not an experiment because the researchers didn't really do anything. They were just watching, like, to see what happened.
Yeah,
Like, they didn't assign someone you smack 2 pokes a day,
right,
2 packs a day. They just did it.
right.
Okay.
They just observed what happened. All right, and here there's a nice little paragraph about confounding variable to start with. I wouldn't expect a student to write this, but this is what they said. A confounding variable is one that is related to the explanatory variable and possibly influences the response variable. Okay, so like we would talk on this one about exercise. Exercise may be related to how much you smoke, and it may have an effect on whether you got Alzheimer's or not. So that's a confounding variable. We can't tell which one is doing it. Is it the smoking or is it the lack of exercise that's causing the problem? So confounding Savannah, for me, confounding always comes down to if I have two things that are possibly causing, but I can't tell which one is actually causing it, I think of that as confounding. And I can't separate those. I can't, I would, if I really wanted to tell the difference, I would need to find a big enough group of people who had smoked 2 packs of cigarettes a day that exercised regularly.
That would be hard to do.
Yeah. And that's why it's confounding, because you have trouble separating the two.
So if you were to like say that exact thing, not word for word, but something like that, but you said it was a lurking instead of a confounding, would that be points off?
Probably, especially since they asked about a confounding variable.
Oh yeah.
Yeah.
Okay, I see it now.
Right. And they went on to say that people who don't smoke may be more health conscious and therefore more likely to exercise. So it's like, now that one I think would be easier to separate, right?
Whether or not you're a health,
Whether or not
you're
you
worked out.
smoke or, there's plenty of people who don't smoke who are couch potatoes.
Yeah. Couch potatoes.
Never heard that?
No, I have from Sammy a long time ago, but I just haven't heard it in a while.
Okay. Yeah. All right. Let's look at this one. How much time do we have?
2 minutes.
2 whole minutes? All right.
Woo.
Look at this one on your own. But there's some good stuff in this one about what are treatments, what are the experimental units, what is the response variable, is there a control group, how can you randomly assign. So the random assignment is something that you need to think about on these, right? And they actually do the hat thing, which I think was kind of cool. They do a random number assignment, but then they also do, the equally sized pieces of paper. So read this and what you should write.
Okay.
So I have a question for that one. So the treatments, I can see I'm kind of just skimming it. Like would be all those 1.25, 2.5.
Right. It's the different sprays.
Yes, and then the experimental units, are those just numbers? Right?
No.
Oh.
The experimental units are the buckets with the insects in them. What are you experimenting on?
Oh. Okay.
Those are the experimental units.
Okay.
So it's like subjects, but it's not people.